So inequalities. So inequalities are different than equations. What does every equation have in it? Alicia, an equal sign. Okay, the equal sign is what makes it an equation. If it's just a bunch of operations and numbers and letters without an equal sign, it's called an expression. Okay, and an equal sign is two expressions that are equal to each other, and they maintain a balance, right? They maintain the mukabala with an equal sign in the middle. And inequality doesn't have an equal sign in the middle. Instead, it has something else in the middle. Like what? Not a squiggly equal sign. Good call, though. A squiggly equal sign means approximately equal to. We don't really do that with equations. Amanda. Yeah, those little like alligator symbols, right? Okay, those are called inequality symbols, right? Those are called inequality symbols. And inequality is a symbol, a thing that says two expressions are not equal to each other. One side is bigger than the other one. Or, this is also an inequality symbol, it's not one we really use very often, is not equal to, okay? So this just means these two things are definitely not equal. Less than and greater than are the ones you should know, okay? We'll talk more about these in a second. So that's an inequality symbol. It tells you that one side of the inequality is bigger than the other one. The bigger one would be heavier, I guess, right? So it weighs it down. This side is heavier than this side. Or this side is lighter than this side, right? So those are the two symbols, greater than and less than. How do you remember which direction they go? Some people use this to remember that the bigger number is on the bigger side of the symbol, and the small side of the symbol, the pointy end, is to the smaller number. Other people use the alligator. Mr. Conklin doesn't like the alligator, I'm told. I don't know why. I like the alligator. The alligator eats the bigger number, right? So this is greater than, the bigger number would be on the right. This symbol, this is a less than. This one is a greater than, the bigger number is on the left. The alligator eats the bigger number, okay? So, greater than and less than, those are these two symbols. Less than and greater than, okay? Well, there's also a situation where not only could the two numbers be not equal, but they can also be equal, okay? So sometimes the boundary number is going to be included, okay? And when that's the case, we use these symbols, which you may not have seen before. Did you see these last year? Okay, so this symbol is a greater than or equal to. If you put a line underneath, it means not only are these less than, but also if they're equal, that's also okay. We'll talk more about that here as we go, all right? So this is a less than or equal to sign, and this is a greater than or equal to sign. So there's four inequality symbols that we're going to use here. Less than, greater than, less than or equal to, and greater than or equal to. All right, so let's talk about what an inequality is here, page 497 in your book, page 497. Okay, so Fisher is mailing pictures to his grandmother, okay? And he has a first-class stamp, a regular stamp that you put in the corner of an envelope, and that stamp allows you to mail up to 13 ounces, okay? And his envelope weighs 2 ounces. And so how much weight in pictures can he put in the envelope and still mail it with a first-class stamp? 11 ounces, right? So this is one you could do it. That was you, Cole, right? I can't tell because you got a mask on. All right, so the weight. So what we don't know is the maximum weight of the pictures. We use a variable to represent that. The weight of the envelope is 2. And the maximum weight of the package is 13. And Cole, in his head, says, oh, the maximum weight of pictures then is 11 ounces. Exactly correct. Now, you could solve this as a one-step equation. Subtract 2 from both sides, you get x equals 11. Okay? Not really worried about that right now. Now, can I put 13 ounces of pictures in the envelope? No, the stamp isn't enough postage. Can I put 8 ounces of pictures in the envelope? Yes. Okay, so 11 is the maximum amount of weight of pictures, but I could put other weights of pictures that are less. So to represent that, instead of saying that the weight of the pictures has to be 11, equal to 11, I can say that the weight of the pictures plus the envelope has to be less than or equal to 13. Okay, this is really what the situation is. That the amount of pictures that I have plus the envelope has to be less than or equal to 13 ounces. Okay, if it's exactly 13 ounces, that's okay. The stamp covers that much. That's why the equal to sign is included. So I could solve this inequality, and then I'll get an answer of X, then the weight of pictures has to be less than or equal to 11. Right? That the amount of pictures has to be less than or equal to 11. So what weights of pictures could I have in the envelope? Anything under 11, like 10 or 9 or 8. Okay, anything 11 or less. And that's what this says. Anything less than or equal to 11 is good. That's the solution to this inequality. All right. So this is a real world situation of inequality to solve, which we're not going to do until we come back from break. And we're not going to do real world ones until we come back from break. But we got to talk about the symbols here and solving inequalities. So the book jumps right into solving inequalities. But before we do that, we're going to talk more about what these symbols mean and how the words maybe translate to the symbols that we use. Okay. So this table on page 498 is an important thing to look at. All right. It gives you the 4 symbols: less than, greater than, less than or equal to, greater than or equal to. And it tells you what words kind of match that symbol. Less than, fewer than, shorter than. Okay. Anything that wants numbers that are smaller than a limit, then you use the less than symbol. Is greater than, is more than, exceeds. Exceeds is a number that means it's more than that number. Okay. They all use a greater than symbol. Now, if it includes the boundary, like the stamps, the pictures problem, where 11 ounces was okay, right? Then it would be less than or equal to, or no more than 11 ounces, or the weight of the pictures is at most 11 ounces. It includes the boundary number. Then your symbol is going to include the equal to part, the little line underneath. Okay, these are all less than or equal to. At or below are words you might see with this one too, right? If it says at, that means that the boundary number is okay, and then also numbers less. Or at or above, the boundary number is okay, but it also includes numbers that are bigger than that. Or no less than. No less than means the boundary is okay. There's no less than 5. 5 is okay, and so is 6, 7, 8, 9, 10, right? Greater than or equal to, right? So we'll see these more when we do word problems, but let's talk about, not in your book now, but on the notes page, okay, where we use these inequalities and why we're going to learn how to solve some of them. All right, so this is on the notes page that I passed out. You have to be 16 years old. You have to be at least 16 years old to get a learner's permit, a driving learner's permit. So if you are told to write an inequality to describe this situation, the inequality is going to have a changing value in it, right? That we need to use a variable to represent that. So the changing quantity in this situation is how old you are. Okay, your age in years. I'm using A for that. If you have to be at least 16 years old, if you're 16 years old, is that okay? Yes. Okay. If you're 20 years old, is that okay? Yes. Or 35 or 100, right? You can get a learner's permit. You probably can't get a learner's permit when you're 100, but okay. So the age then has to be greater than or equal to 16 because 16 is okay. So 16 is included, and the symbol is the greater than or equal to symbol. So what values of A will make this true? 16, 17, 18, anything bigger than 16. Okay? That matches these words. All right, here's the next one. You must be taller than 40 inches. You must be taller than 40 inches to ride the Big Thunder Mountain Railroad at Disney World. Okay? Lots of rides, have these height requirements on them. Why do these rides have height requirements on them? If you're too small, what can happen? You can fall out, right? It's a safety thing, right? So did some people cheat on these things when they were smaller and put like little pieces of styrofoam in their shoes so they get an extra inch? We did in my family. Okay, because I got 3 kids, I have twins, and then another one who's a year and a half younger. And the 1 year and a half younger, he did not want to be left out when we went to Busch Gardens. We had season passes to Busch Gardens when we lived in Virginia. And he couldn't go on Alpengeist because he was too short. So I put these pieces of styrofoam in your shoes. Then he got in under the thing. Okay, Roman.
What's Busch Gardens?
Busch Gardens is an amusement park in Williamsburg, Virginia. It's a good park. It's really cool. Okay. All right. So, Big Thunder Mountain Railroad, that's the train. It goes around the mountains right into Disney World. You have to be taller than 40 inches. Taller than 40 inches. Okay. So, why are there 2 boxes here? What's in the first box here? Cole. Defining the variable. And what is the variable for this situation? What is the changing value? I for inches, okay? Or some people might say H for height, right? H for height is what I said. If I just say H for height, I'm going to lose a half a point. Because, is it height in feet, meters, centimeters? Yes, Roman? There's units, right? This tells me that my height has to be in inches. So when I define the variable, I have to say what the units are. It's probably the most important part. This is why Cole saying I equals inches is really a safe way to go. Okay. All right. What is the inequality for this situation? You have to be taller than 40 inches. What is the inequality? Cole? Okay. So if you are 40 inches tall, can you go on the ride? Are you taller than 40 inches if you are 40 inches tall? No. So should the equal to sign be included in this one? No. Because if you're 40 inches tall, you're not taller than 40 inches, you can't ride. Okay, that's the difference. 40 itself, exactly 40 inches, you're out of luck because you're not taller than 40 inches. Okay? You'll see in the examples on the next page, maybe it comes a little more clear, but there's no equal to here because 40 inches itself is not tall enough to ride the ride. If you're 40 inches and a quarter, you're good to go. But exactly 40 inches, you're very disappointed and crying. And then the next time we go, we'll put some styrofoam in your shoes. Yes, Roman?
Wouldn't the arrow be the other way? So
height. Your height has to be greater than, the height has to be a bigger number than 40, right? I'm 5'10". How many inches tall am I? Oh, I'm 5'11". You're right. I'm not 70 inches, but that's because I said I was 5'10", but I'm 5'11". 71 inches. Can I ride on this ride? Yeah, 71 is bigger than 40. I'm good to go. So are all of you, right? Because no one's 3.5 feet tall in here, which is what 40 inches is, right? Not even 3.5 feet. 3 feet, 4 inches. Pretty short. That's because Big Thunder Mountain Railroad doesn't go upside down, so you don't have to be that tall to ride that one. If it goes upside down, then you have to be taller typically. All right, so here's 3 more examples. There's 2 boxes on each one. Why is the first box there? Evie, what do you do in the first box? Correct, define the variable, and then write your inequality. Go ahead and take a shot at these. Chad, what are you doing on your Chromebook? Nothing, that's correct. Good answer. Nothing. How about you? Nothing. You're good too. You don't need it for the rest of the class. You need it. How's it going? Okay. What is the value that is changing, right? The number that can change in this situation, the measurement that can change in this situation, and then what is the inequality? Yes, good, Holly. Yes, yes, yes. Good, keep going, do all three of them. Do all three of them. Anyone at home still, I wonder? Let's see. Nope. Just talking to the camera now. That's okay. All right. So Ledyard is in the COVID red zone, which we have been for like 6 weeks. If there are more than 2 new positive cases in town in the week, okay? The actual requirement is 15 cases out of every 100,000 people. Ledyard only has 15,000 people in it, so only a couple people have test positive, then we're in the red zone. All right, so what is the variable here, Roman?
I used C for COVID cases.
C for COVID cases works. I used P for positive cases. That's okay. This is a count of things, right? There are no units here. It's just a count of how many cases there are. So C equals cases or COVID cases or positive cases, anything like that. All right. And what is the inequality? Alicia? Greater than without the equal to sign, right? Because if there's 2 cases, we're okay. It's bad if there are more than 2 cases. So it's P is greater than 2. Then we're in the red zone. If P equals 2, we're fine. Hopefully next week. I don't know. We'll see. Okay, next one. Water boils when the temperature is at or above 212 degrees F. What is the variable definition for this one? Let's see if someone new can participate here. James. T equals temperature, says James. That's what I have. Except if you stop there, you will lose a half a point. Is it Kelvin, Celsius, or Fahrenheit? Fahrenheit. There are units associated with this one. So you have to include the units when you define the variable.
And then it's 212 Fahrenheit. Greater than or equal to T.
Okay. So if the temperature is 75 degrees, is this true? If the temperature is 75 degrees, that 212 is greater than or equal to 75? This is backwards, right? This is looking for temperatures that are below 212. Not going to boil if it's below 212 or at or below, okay? So instead, James, you want to do what? Okay, so you could flip this one the other way. Not typically how we write these, but you could say that 212 is less than or equal to T, or the way I put it under the box, T is greater than or equal to 212. If it's 212, is water boiling? Yes, because it's at or above, right? At or above. So that's why the equal to sign is included, because it includes the 212 degrees. Okay, last one. A flyweight fighter's weight can be at most 125 pounds. At most 125 pounds. These are UFC weight classes, right? For UFC fighters and boxers too. I don't know if the numbers are the same. So what is the variable in this situation? What is the variable in this situation? Roman.
I did W for weight of fighter.
W equals weight minus a half a point. Again, is it in kilograms, Roman? Tons?
Pounds.
Ounces? Pounds, right? You have to specify because the inequality would be different if it was in grams, right, or ounces, and it will tell you in the problem what units this number applies for. Okay, it's 125 pounds. So you have to say pounds here. You could write out pounds if you don't know that LBS is the abbreviation for pounds. Okay, what is the inequality? What is the inequality? Cole.
W is less than or equal to 125.
W is less than or equal to 125 is exactly what I have.
Hooray, I'm correct.
At most, 125 means that 125 pounds is okay. So that's why the equal to sign is included. If he's 115 pounds, he's also good, okay? Actually, if he weighs less than 115 pounds, that's a straw weight I never even heard of until I called this up in the thing. Yeah. But you can always fight higher in any of those kinds of things if you wanted to, right? Some wrestlers have to do that, I guess, right? Okay, so translating words to inequality symbols. We'll do more of this when we come back from break. Okay, we're not going to do any real world stuff today. We're just going to go over solving inequalities here for the rest of today's lesson. Go back to the book to page 498. Solving inequalities. Oh, I forgot to do my summary in the last class. Well, luckily I'm recording it. Okay, so you will notice that this problem looks a lot like the one-step equations, page 498. A lot like the one-step equations that we solved last week. They're done exactly the same. The goal here is to get the variable by itself on one side and the number on the other side, except for now it's an inequality symbol instead of an equal sign. So undo addition by subtracting from both sides, and x is greater than 7. Any values of x greater than 7 will make this true. If x is 10, yep, 13 is greater than 10. If x is 7.5, yep, 10.5 is greater than 10. Okay, so how many solutions are there to this inequality? How many solutions are there? How many numbers will make this equation true? I mean, this inequality true? 2, 3, Kylie? An infinite number, right? There's an infinite number of solutions. Anything that's bigger than 7 is a solution, okay? So that's one of the big differences between an inequality and an equation. An equation, there's only one number that you can put in for x that makes it true. In an inequality, there's an infinite number of values that make it true. There's also an infinite number of values that make it not true, right? If they're smaller than 7. Yes, Roman?
Why did you cross it with some under if that's the trick?
I crossed this out because we don't worry about doing checks on inequalities, okay? And we could check the boundary, but then it's a little confused. I just don't think the check is all that useful, okay? Now you can sort of check it mentally, put 0 in for the variable and see if it's supposed to be the right answer. If I put 0 in here, is that true? 0 is greater than 7? No. So that means in the original equation, if I put 0 in there, it should not be true. And it's still not true. So, but we don't ask you to do checks on inequalities. So some of you will be happy about that because you don't like checks. Okay, this one, -6 greater than or equal to n minus 5. Now, when we did equations, some of you don't like having the variable on the right side of the equation, right? And so you can switch it. If it's an equation, you just switch the sides, okay? In an inequality, what do I have to do if I switch the sides of this inequality? Okay, if I wanted to write it like this, n minus 5 on this side and -6 on this side, is that okay? Like that? The way it was written here? No, it's not, right? Because over here, I need the n value to be less than -6. So over here, this side has to be less than. So what happens is if you switch the sides, you have to switch the direction of the inequality symbol, okay? So that's one of the main differences between solving equations and solving inequalities. Roman,
Somebody threw something.
somebody just threw something?
I didn't throw it.
Oh, you're playing with your pen?
Yeah.
Launching pen pieces? Yes, this is a common middle school boy activity that I have seen in many years of teaching. Okay. And that's because, right, it's the inequality is like this. If I switch the order, I have to switch the direction of the inequality symbol, okay? So we've covered two big differences in equations and inequalities. The first one is equations only have one solution and inequalities have an infinite number of solutions. The second one is if you switch the sides of an inequality, you have to flip the sign, okay? And we'll get to the third and most critical one in a little bit here. All right, so again here, we add 5 to both sides, and -1 is greater than or equal to n. So I'm not going to have you guys do these problems. We'll just go through them quickly here. A minus 3 is less than 8. What is my step to solve this inequality? What is my step? Nate, add 3 to both sides, you say. Add 3 to both sides. That's the step. Add 3 to both sides. Adding 3 to this side makes this go to 0, leaving me with just A. Adding 3 to this side gives me 11. So A is less than 11. That will make this equation true. Any value of A less than 11, this inequality rather will be true. What is my step in letter B here? Emma, what is my step to solve letter B? Okay, so the 0.4 is in the way of having the variable by itself, but it's added on to y. So to undo it, I'm going to subtract 0.4 from both sides. Okay, so subtract 0.4 from both sides. You don't have to rewrite this here. I don't know why I did that. Actually, probably Mrs. Woodruff did it. I'll blame her. Minus 0.4 on both sides. That's 6.6. Okay, so y now by itself has to be greater than or equal to 6.6. If it is equal to 6.6, this comes out to 7 is greater than or equal to 7. Because the equal to sign is here, that's still okay, right? All right, so that's those two. So instead of doing checks on these solutions, sometimes, very often, you're asked to graph on a number line the solution, okay? So graphing the solution means we want to write an arrow, okay, that shows or covers up all of the solutions to the inequality. So you solve, here's A plus a half is less than 2. Subtract a half from both sides and you get A is less than 1.5. I wish they wouldn't use a fraction one for this example, but okay. So A has to be less than 1.5. It does not include 1.5, right? Because there's no equal to here. All right, so what numbers will make this inequality true? Well, any number that's less than 1.5 is what I want my number line to show. So is 1 a solution? Is 1 less than 1.5? Yes. 0, negatives, okay? But what about 1 1/4? Yes, or 1 3/7, or 1 5/11, or anything less than a half, right? Doesn't matter, I can get really close. But 1.5 itself is not a solution. Yes, Nate? What did I do?
You were moving around.
Okay. So in order to show that everything right up to 1.5 is a solution, but not 1.5 itself, we use an open circle on the number line. The open circle at 1.5 means everything right up to 1.5 is okay, but 1.5 itself is not okay, right? Because it doesn't include the equal to sign in the inequality. So an open circle is used for less than and greater than without the equal to. And then you draw your arrow in the right direction. We want numbers that are less than 1.5, so it's everything to the left. And you have to draw an arrow in there because it continues, like -1,000,000 makes this true, right? So this just keeps going forever. If it's an equal to symbol, then that value, the border value, is part of the solution, and we show that by putting in a closed circle, a filled-in dot, instead of an open dot. All right, so this one, h plus 4 greater than 4, what is my first step or only step in solving this inequality? What is my step in solving this inequality, h plus 4 greater than 4? What am I going to do to both sides? Amanda? Subtract 4 from both sides, and I get h is greater than 0. 4 minus 4 is 0. H is greater than 0. What is my number line going to look like for this solution? How do I show a number line of H is greater than 0? What am I going to start with? At 0. What am I going to have at 0? Open circle. Open circle at 0 because it doesn't include the equal to. And which way is the arrow going to go? To the right or to the left? I want values that are greater than 0, covered up by my arrow. Kylie? So it goes to the right. It's an open circle at 0 and an arrow to the right. That's the graph of this solution. Every number underneath this arrow makes that inequality true. Anything bigger than 0. But not including 0. Because if I put 0 in here, I get 4 is greater than 4. That's not true. 4 is not greater than 4. 4 is equal to 4. Okay, next one, x minus 6 less than or equal to 4. What is my step for solving this one, Chad? What is my step for solving this equation? What am I going to do to both sides of this equation to get the x by itself? What do I have to get rid of to get the x by itself? Matt? I'm going to add 6 because this minus 6 is what's in the way on the x side of this inequality. So I'm going to add 6 to both sides. This goes to 0. And this side is 10. So I'm left with x is less than or equal to 10. X is less than or equal to 10. Describe the graph of this solution. X is less than or equal to 10. What color, what kind of circle at 10, and which way does the arrow go? Cole's all over it. He is answering every question today. Did I call on Cole? Yes?
Yes.
Evie says yes. Cole, what's it look like?
The full circle with the arrow going.
Closed circle with an arrow going to the left. Is that what it looks like? Absolutely correct. Closed circle because the symbol includes the equal to. So 10 itself is a solution. So that's why it's closed circle here. And I want numbers less than 10. So the arrow goes to the left, covering up 9, 8, 7, 6, all the way to infinity in the negative direction. Okay? So graphing on a number line, something that you do with inequalities. And when we come back after break, we'll practice that backside of that worksheet to match up the inequalities with the graphs. Okay? You don't have to do that now. All right, so that was adding and subtracting one-step equations, inequalities. Multiplying and dividing one-step inequalities is going to bring the main difference between solving equations and inequalities. All right? So, I'm going to skip this and go to this, which says, an inequality remains true if you multiply or divide both sides by a positive number. Okay, so if I multiply or divide both sides of the inequality by a positive number, it's basically the same as what we did with equations. Okay? C is greater than 0 as part of this rule. That's the number I'm dividing both sides by or multiplying both sides by. C is greater than 0 means that C is positive. Okay? The number that I'm multiplying both sides or dividing both sides by, if it is a positive number, then everything is just the same as equations. I undo multiplication by dividing both sides by 8, and I get x is less than or equal to 5, right? Because 8 divided by 8 equals 1, and so 1x is less than or equal to 5. If it's division that I have to undo because the variable is being divided by a number, I undo that by multiplying both sides. So I multiply both sides by 2. 2 divided by 2 here is 1. 2 times 7 is 14. So D is greater than 14. And you see up here, if I put in 20, if D is 20, 20 divided by 2, 10 is greater than 7. Right? True. Okay, so any value of D greater than 14 will make this inequality true. Okay, so that is multiplying or dividing by a positive number. Letter A here in the got it. What is the first step, the only step? What is the step for solving letter A? Holly. What do I have to do to both sides of this to get the solution? Divide by 4, did you say? Yes, that's correct. Be confident. Divide both sides by 4 to undo multiplication, right? I undo this multiplication by dividing. X is less than 10. 40 divided by 4 is 10. X is less than 10. If I were to graph this on a number line, it would be an open circle and an arrow to the left. What do I do for letter B? What do I do to solve letter B? Kenny G. What am I going to do to both sides of this inequality to solve it?
X divided by 7, that's division, right?
Yes, so I undo that by doing what? Correct. What am I going to multiply both sides by? 6. The 6 is not in the way of the variable being it by itself. It's the 7 that I have to get rid of. So I'm going to multiply both sides by 7. Okay, multiply both sides by 7. 7 divided by 7 is 1. So X on this side and this side is 42. Okay, and again, if you don't like this, you don't like it like this, you could change this problem to this. If I switch the right and left sides here, I need to flip this inequality symbol, right? So I could solve it that way, times 7, and X is less than or equal to 42. These are the same thing, right? 42 is greater than or equal to X. The same thing as X is less than or equal to 42. All right, so there must be something going on if I only talked about multiplying or dividing by positive numbers. And that is true. This next thing is the biggest difference in solving inequalities, between solving inequalities and solving equations. We call it the glitch. Okay? The glitch is a procedural, weird thing that you have to do when you solve inequalities. And that weird thing is that if you solve an inequality by multiplying both sides or dividing both sides by a negative number, if you multiply or divide both sides by a negative number, you have to flip the direction of the inequality symbol. We could go through a long pattern of example of why this happens, but we don't really have time. It's not really worth it. Okay. So instead, we're just going to say you have to just press the I believe button. Okay. And remember that this is the case. When you multiply or divide both sides of the inequality by a negative number, you have to flip the direction of the inequality symbol. So, for example, negative 2g is less than 10. I undo the multiplication here by dividing both sides by negative 2. Well, when I divide both sides by a negative number, this less than symbol flips to greater than. And my answer then is that g is greater than negative 5. Okay? And you can see, right, 0 is over here, right? 0 is greater than negative 5. If I put 0 into this inequality, 0 is less than 10. That's true. If I didn't flip the direction of this, right, then I would be looking at values of g less than negative 5, and then that would make this not true because I'd end up with a positive number here, big positive number. So when you divide or multiply both sides, here's the multiplication example, right? Dividing by negative 3, I undo by multiplying by negative 3, so that goes away. But when I do that, I flip the direction of the inequality symbol. And my answer then is x is greater than or equal to negative 12 instead of the original less than or equal to. All right, so one got it problem here. K divided by -2 is less than 9. What is my step for solving this inequality? What is my step for solving this inequality? Amanda.
Multiply the -2.
Multiply both sides by -2. And when I multiply by a negative on both sides of the inequality, that's the glitch. So I have to change the direction of the inequality symbol. You could just write this work like this. You just do times -2 here and -2 times. And then you write this, the answer. That K is greater than or equal to -18. Switch the direction of the inequality symbol because I multiplied both sides of the equation by a negative number. What does the number line look like for this problem? K is greater than -18. What does the number line look like? Roddy Boss, what does the number line look like? K is greater than -18. So at -18, what am I going to have at -18? An open circle or a closed circle? Okay. Does my answer include the equal to sign? No. So if it doesn't include the equal to sign, it's an open circle. Okay, so an open circle at -18, and which direction is the arrow going to go from there? To the right or to the left? I want it to cover up values of K that are greater than -18. So if from -18 I cover up things to the left, like -20 and -30, are those greater than -18? So it's an open circle and an arrow to the right. An open circle and an arrow to the right. Okay. You guys did a lot better than last class. So this is key here. This is on your notes page. Three big differences in solving equations versus solving inequalities. Okay, first, equations have only one value that will make the equation true this year. Next year, you'll find equations that have different answers. They can have no solution. Okay, but this year, equations have only one number that will make the equation true, and inequalities have an infinite number of values you can put in to make them true. It's okay on equations to just flip the sides. You don't have to worry about anything. But when you switch the sides in an inequality, the inequality sign has to flip with it, right? Pointing to the X, over here it still has to point to the X, okay? And finally, the most significant one, and the one that people will forget, right, Maggie, is the glitch. Do not forget the glitch. That when you solve an inequality and you multiply or divide both sides by a negative number, you have to flip the direction of the inequality sign. Okay?